guys, I am inviting you once again to watch so as I discuss with you the topic on the basic rules in determining the indefinite integral of the given trigonometric functions. Are you ready? Okay. So again, our lesson is all about the indefinite integral of sine, cosine, and tangent functions. We have here the very first rule, and that is of course the integral of sine function, wherein the given integrand sine x, wherein x is a function of sine, and its integral is denoted by this formula. As you notice here, we have the indefinite integral of sine x dx is equals to negative cosine x plus c. Again, the integral of sine is simply negative cosine. Okay, now let's take an example. So what if our example here is this one? Okay, we integral quantity 4x minus 2 dx. So first we have to let u, that is 4x minus 2. After that, we're going to take its derivative. So the derivative of this is simply we have du equals 4 dx. Okay, to remove this 4, because we need to get an integrating factor, we are going to divide both sides by 4. Okay, so therefore, our integrating factor here is 1/4. This integrating factor is needed for us because the value of the derivative of the function of sine is not exactly the same as dx. Okay, so the next step we are going to do therefore is we have here 1/4 the indefinite integral of sine 4x minus 2 dx equals, of course, this 1/4 now is already separated integral sign. So then we all know that the equivalent integral of sine is negative cosine. So we come up now of negative cosine quantity 4x minus 2. Okay, then of course the last step here is we are going to affix now our integrating constant, which is plus c. As we simplify it further, negative 1/4 cosine quantity 4x minus 2 plus c. This is now our indefinite integral of sine quantity 4x minus 2 dx. Okay, what if we have another example here? Our second example here, guys, is the indefinite integral of sine quantity. We have x over 3 dx. Okay, so from our first example, we need to get or let that first of the function as u. So if we let u equals x over 3, okay, then what will happen next is simply we're going to get its derivative. So u becomes du equals x over 3, therefore is 1/3 dx. Okay, once again, for us to eliminate this constant, and this constant now would be considered as our integrating factor, simply we are going to multiply both sides by 3. So this will be cancelled out. So we have now, therefore, we have 3 du. So what does this mean, guys? Our 3 here becomes our integrating factor. So from our next step here is 3, then the indefinite integral of, we have sine x over 3 dx, okay, equals, as we have already hit integrating factor, so we have 3, then quantity, we have the our sine has an integral of negative cosine, so we have x over 3 plus c. Okay, so as we simplify it further, we come up now with negative 3 cosine x over 3 plus c. This is now our integral of sine quantity x over 3 dx. We come up now with negative 3 cosine x over 3 plus c.
Okay, there you have it, guys. The integral of sine function, wherein we are to remember that the integral of sine is simply negative cosine. Now, let's proceed with the second trigo function, and that is cosine. So the integral of cosine function, given the integral cosine x, wherein x is a function of cosine, it's denoted, of course, by cosine x dx. And of course, the integral of this cosine is simply sine. Okay, let's take another example here for cosine.
Here is the indefinite integral of cosine 5x plus 3 dx. So again, our first step is we let u as 5x plus 3. After letting u, we get its derivative. So we have u becomes du equals 5 dx. Afterwards, we need to get its integrating factor because we all know that the value of the derivative of the function of cosine is not exactly the same as dx. So we need an integrating factor by dividing both sides by 5. Cancelled out. So therefore, we have an integrating factor of, yes, you're right, it's 1/5. So 1/5, the indefinite integral of, from our given, it's cosine quantity 5x plus 3 dx equals, of course, we have the 1/5. And what is now the integral of cosine? The integral of cosine from our formula, it's simply sine. So we have sine quantity 5x plus 3. Then of course, do not forget to affix our c, or integrating constant, plus c. So therefore, this would becomes now our final answer, which is 1/5 sine quantity 5x plus 3 plus c. If we take another example, okay, we have the indefinite integral cosine. We have quantity negative 3x plus 2 dx. Again, from our steps, we let u, from the given function, let u equals negative 3x plus 2. After that, we get its derivative, so we have du equals negative 3 dx. And of course, what will happen? We simply divide both sides by negative 3. So we come up now with our integrating factor is therefore negative 1/3. With that negative 1/3, of course, we are now ready to get its indefinite integral of cosine quantity negative 3x plus 2 dx equals, we have negative 1/3. And then, of course, our integral of cosine is simply sine. So we have sine quantity negative 3x plus 2, and of course, plus c. So therefore, our integral of cosine quantity negative 3x plus 2 dx is simply negative 1/3 sine negative 3x plus 2 plus c. This is now our final.
Okay, so that is the integral of cosine, and that for integral of cosine is simply sine. Now, let's proceed with the last trigo function that we're going to discuss, and that is the integral of tangent function. Okay, given the integrand of tangent x, wherein x is a function of tangent, and its integral is denoted by, of course, we have here um, uh, tangent x is equals to the ln of the absolute value of secant x. Okay, again, the integral of tangent is simply the ln of the absolute value of secant x. Now, what if we are going to have an example?
Okay, our example here is the indefinite integral of tangent 6x dx. So again, our first step is to let u equals 6x. Then we get its derivative. So we come up now with du equals 6 dx. We divide both sides by 6. So we come up therefore with integrating factor of 1 over 6. So we come up with 1 over 6 indefinite integral of tangent 6x dx equals. With that, copy our integrating factor. We have 1 over 6. And we all know that tangent has an integral of ln of the absolute value of secant. So we have 6x. Then last step is to affix our constant of integration. So therefore, the indefinite integral of tangent 6x dx is simply 1 over 6 ln of the absolute value of secant 6x plus c. Okay. What if we have here an example, another example? Okay, indefinite integral of tangent 2 tangent quantity negative 3x plus 6 dx. So you notice this time we have a constant here, or simply a numerical coefficient. So what do we do with that constant? We simply pull it out or separate it out from our integrand. Okay, but of course we come up now with 2 definite integral of tangent quantity 3x plus 6 dx. With this, we are now ready to get or let the value of our function as, okay, so let u therefore is negative 3x plus 6. After that, we are now ready to get its derivative. So du equals negative 3 dx. Divide both sides by negative 3. Okay. So therefore, our integrating factor here is negative 1/3. But of course, do not forget that we have already separated constant 2 here. So that is already written here. And then, afterwards, from our given definite integral of tangent quantity negative 3x plus 6 dx is simply what? We have the integrating factor negative 1/3 times 2. It's simply negative 2/3. Then of course we have the integral of tangent is simply the ln of secant. So we have ln of absolute value of secant. We have therefore quantity negative 3x plus 6. And of course, final is to place or affix now our constant of integration, which is now c. So again, the indefinite integral of 2 tangent quantity negative 3x plus 6 is simply negative 2/3 ln of the absolute value of secant quantity 3x plus 6 plus c. That is now our final.
Okay, so that is the integral of tangent function, which is equivalent to the ln of absolute value of secant x. So there you have it, guys. And as we sum up our discussion for the first 3 trigo functions we have for the integral of sine function, always remember that the integral of sine function is simply negative cosine. For integral of cosine, simply it's sine. And of course, the integral of tangent function, it's simply ln of the absolute value of secant. So again, guys, that is our lesson. And of course, do not forget that when we are dealing with trigo functions, we need to let u to get the derivative of the given integrand to have an integrating factor. So guys, that ends our discussion, and thank you for watching and hoping you have learned something today. Have a nice day, and again, see you in the next lesson for another exciting and comprehensive discussion of our topic. Thank you guys.